Hello, welcome back to Learn Physics. In today's topic, we are starting a new chapter, Thermodynamics. So, what is meant by thermodynamics? Thermodynamics is the branch of physics which deals with temperature, heat and all. Okay, so about temperature, thermo means temperature. About temperature, it's a study about temperature, that is thermodynamics. Okay, so first we are going to study about what is meant by temperature and what is meant by heat. So already we learned this in the previous chapter, thermal properties of matter. We learned about heat. Heat is a form of energy which gives a warmth, we told, isn't it? The energy which is, see, when the temperature is moving from higher temperature region to lower temperature region, isn't it? So then what is transferring over here? Heat energy is transferring from higher temperature to lower temperature. Energy is transferring. Temperature is moving from higher temperature to lower temperature region, means its heat energy is transferring, isn't it? Heat energy is transferring from one point to another point. Now next we are going to consider about thermodynamic system. What is meant by thermodynamic system? Thermodynamic system means if we are considering a large number of molecules under consideration, then we can say it as thermodynamic system. A system of particles. System of particles and rotational motion we learned. In that, what was system of particles? System means it's in a rigid body, n number of particles are there. Same way here also we will be considering. So suppose if I am considering a gas, it will be having n number of particles, isn't it? So that particles all together we will say it as thermodynamic system. So the system which is under observation has many number of molecules, then we will consider it as a system, that is thermodynamic system. So while we are explaining thermodynamics, don't get confused what is meant by the system. So that's why it's initially itself we are telling what is heat, and heat, it is a form of energy and it is transferring from higher temperature region to, which transfers from high temperature region to low temperature region. Okay, then next is thermodynamic system. Thermodynamic system is the point or the gas which is under consideration will be having its large number of particles, then we can say it is a thermodynamic system. Okay, so next we are going to study about thermodynamic equilibrium. What is meant by thermodynamic equilibrium? Equilibrium stage means, what is the meaning of that? See, they are macroscopic variables. What are that macroscopic variables? Pressure, volume, temperature, mass, etc. All these are not changing with respect to time. Not changing with respect to time, then we can say it is with respect to time, then we can say the system is in thermodynamic equilibrium. Pressure, volume, temperature. So these macroscopic variables are not changing with respect to time. Then we can say it is under thermodynamic equilibrium. Understood what is meant by thermodynamic equilibrium? So if we are considering all these macroscopic quantities or physical quantities that are not changing with respect to time, then we can say it is under thermodynamic equilibrium. Okay, so the next one is, next we are going to study about the Zeroth Law of Thermodynamics. Zeroth Law of Thermodynamics. This gives the concept of temperature. Okay, this is giving a concept of temperature. Okay, so first we are considering two systems, A and B. Okay, A and B are separated with a adiabatic wall. Adiabatic wall. Adiabatic wall means, what is meant by adiabatic wall? Adiabatic wall means no heat transfer is between these two systems, and it is thermally insulated outside. Outside part is thermally insulated. This is thermally insulated, and this is separated by an adiabatic wall. What will happen? No heat transfer. So nothing will be happening. That is, it will be, if PA, VA is the pressure and volume over here, PB, VB is the pressure and volume over here, and it will exist like that because it is thermally insulated. So no heat energy will be released, or heat energy can't be accepted from towards inside, or we can't release heat energy also from the systems. So it will be existing as such. So instead of an adiabatic wall, if I am using a diathermic wall, this is thermally insulated outside. If I am using a diathermic wall, it is a diathermic wall. If that means heat energy can be transferred. Heat energy can be transferred between, and the new heat energy will be, but it is thermally insulated outside. So next it will be reaching to PA dash, VA dash, and here PB dash, VB dash. That is, heat energy is transferring till both the systems are having same temperature. Since both the systems are having same temperature, heat energy will be transferring from one system to another. Okay, so it will be reaching to the pressure also will be varying, volume also will be varying. In different pressure and volume they will be attaining. After a particular interval of time, no heat transfer between, isn't it? So the system won't be having any heat transfer between the system. So it is called as then we can say it is under thermodynamic equilibrium state. Okay, after that no heat transfer, isn't it? So we can say that pressure, volume, temperature and mass. Pressure is not changing, volume is not changing, and mass is not changing. Nothing is changing between the system. So we can say that it is achieving the thermodynamic system or equilibrium. Okay. So now coming back to the zeroth law of thermodynamics. Here I am considering, see, these two systems are A and B separated with an adiabatic wall. And now I am considering this with an diathermic wall. Here it is in diathermic wall. I am taking a system C over here. Okay, A is in thermal equilibrium with C, and B also will be in thermal equilibrium with C. So first I am considering two systems A and B separated with an adiabatic wall. Okay, so no heat transfer between. Nothing will be happening between A and B. Now I am taking a third system C, which is separated with a diathermic wall, is connected with both A and B. So between the diathermic walls, what will happen? Heat energy will transfer, right? So the heat energy will be transferring between A and C, and it will be transferring between B and C. So what will happen? A and C are in thermal equilibrium, B and C are in thermal equilibrium. Then what we can say? Then A and B also will be in thermal equilibrium with each other. So that is called a zeroth law of thermodynamics. So zeroth law gives the concept of temperature, thermal equilibrium. So we are getting a concept of temperature over there. So what does the law states? It is if the system A is in thermal equilibrium with the C and another system B is in thermal equilibrium with C, then we can say that A and B are in thermal equilibrium with each other. Now how we can define temperature? So temperature is the quantity or physical quantity which determines whether the systems are in thermal equilibrium or not. Whether the system is in thermal equilibrium, which quantity is determining whether they are in thermal equilibrium or not? The quantity temperature is the quantity which is determining whether A and C are in thermal equilibrium or B and C are in thermal equilibrium, isn't it? So the temperature is a quantity which determines whether the systems are in thermal equilibrium or not. Okay, like that we can define temperature. So about the not the definition, concept, what is meant by temperature. So simply we can say it is the measure of hotness or coldness of the system, or that is called a temperature, like that definition goes. But what is that what is the measurement? That means it is the whether the system is in thermal equilibrium or not, using which the two systems while we are considering, they are in thermal equilibrium means their temperature are equal. So the quantity which determines whether the system is in thermal equilibrium or not, that is called as temperature. Okay, so next we are going to study about the internal energy and work done, heat, all those things we learn. Okay, next we are considering about heat. Heat, already I told you what is meant by heat. Heat is the energy which moves from higher temperature region to lower temperature region, that is called a heat energy, isn't it? Heat is an energy, it is a form of energy which transfers from higher temperature region to lower temperature region till it reaches to the thermal equilibrium. Till it reaches the thermal equilibrium, the energy is transferring from higher temperature region to lower temperature region. Due to that only the temperature is varying. Since energy is varying, temperature also will be varying. Okay, so next, so the system is getting temperature or it is losing temperature. Because of that, what will happen? Internal energy. It is getting energy internally. So what it will happen when it is getting energy internally? Molecules inside the gas will be getting kinetic energy and potential energy. That heat energy will be converting to molecular kinetic energy and potential energy. Kinetic energy means as it is getting temperature, what will happen? Its kinetic energy will be increasing, movement will be faster. So its kinetic energy will be increasing, or potential energy also will be increasing. It will be moving its position also, isn't it? So it will be getting kinetic energy as well as potential energy. So the sum of these two is called as internal energy. Sum of internal potential energy and kinetic energy of the system, that is called as internal energy of the system. Okay, so if I am considering an ideal gas, for an ideal gas while we are considering, it has internal energy depends only on temperature, depends only on temperature. If temperature is constant, then internal energy will be zero. Internal energy will be zero. So internal energy we will be considering it as the representing with the symbol U. Okay, so if temperature remains constant, internal energy will be zero. That is, if there is no change in temperature, if delta T is equal to 0, then delta U, change in internal energy, also will be 0. Okay, internal energy remains constant. Okay, if temperature is constant, internal energy remains constant. If there is no change in temperature, change in internal energy also will be 0 for an ideal gas. In the case of a real gas, so because ideal gas means it's not a real situation, isn't it? So if we are considering the real gas, internal energy depends on pressure and volume. Okay, it is depend as pressure increases, what will happen? The temperature also, as pressure increases, volume will decrease. According to that also internal energy will be changing. But here while we are considering the ideal gas in an isothermal condition, or temperature remains constant, change in temperature is 0, change in internal energy also will be 0. Okay, so energy we are giving to the system, it is converting to internal energy. Internal energy means it is kinetic energy and potential energy. We know that is energy and is related with the work. Okay, it is helping, it's doing work, it's moving. Because of that energy it is moving, that means it is doing some work. Okay, so this work and energy are not considered as state variable, they are not considered as state variables, but they are the variables used for the change in internal energy, isn't it? They are used to, to change the internal energy, or it is used to this heat energy and work. So the heat energy and work are not considered as the state variable, but they are considered as the different modes of heat transfer. Okay, different modes of energy transfer for changing the internal energy of the system. So heat work and heat energy are not considered as a state variable. It is considered as the different modes of energy transfer. It is only considered as the energy transfer to change the internal energy. Okay, so work done and heat energy are considered as the different modes of energy transfer to the system or from the system. So we can take energy from the system, or we can release energy to the system, isn't it? Or from the system or to the system, both are applicable. Okay, we are giving energy to the system, or we are taking energy from the system. In those two cases, since we are taking energy or giving energy, internal energy will be changing. Okay, so that is, it depends on it is used to change the energy of the system, internal energy of the system. Okay, so clear what is meant by heat, internal energy and work done. Okay, so next we are going to study about the first law of thermodynamics. Okay, so next is first law of thermodynamics. First law of thermodynamics. What is meant by first law of thermodynamics? Say, if I am giving dq amount of heat energy to a system, so if that heat energy, in which and all ways we will be using? I am giving dq heat energy to the system. If I am giving dq heat energy to the system, this will be used to change the internal energy of the system. It is du, change in internal energy. dq is the amount of heat energy change. So the system will be having one heat energy. Suppose it is having some amount of heat energy. To that I am giving an extra heat energy of dq. So extra heat energy, change in heat energy which is happening to the already existing system, that is represented as dq. That will be used for changing the internal energy, and the rest of the energy will be used to do work to the environment. Okay, so work done. So the amount of energy given to the system is used for changing the internal energy of the system and for doing the useful work to the environment. So this is called as first law of thermodynamics. According to this law, the heat energy given to the system is utilized to increase or decrease the internal energy or to do the work. Okay, here the sign convention is very important. Okay, if I am giving energy to the system, then we can consider that dq as positive. Okay, then if I am taking energy from the system, then dq will be considered as negative. Okay, then du, internal energy, before that I will consider it as work done. Work done, how we can consider? Work done by the system. If system is doing some work, then I will consider work done as positive. And if work is done on the system, then I will consider dW as negative. Work done will be considered as negative. And temperature, if temperature increases, internal energy will be positive, and if temperature is decreasing, then internal energy will be negative. These three sign conventions you should remember. Okay, any one positive, all the positive quantities you just keep it in mind. Then we can consider the other will be negative. negative. Otherwise it will be getting, if this is positive, this is negative, like that or not, if you are studying, it will be confusing for you. Better than that, energy is giving to the system, we are giving extra, so it is positive. Okay, a work is done by the system, I have more energy, so I am doing work, so I am positive. So T is positive, T is increasing, so increasing means positive, U is positive. All the positive things, you keep it in mind, always be positive in life also. Okay, don't forget that. Okay, so all the positive things, keep it in mind in all the ways. Okay, then if it is opposite means it will be negative, that is understood. Okay, so always keep all these three in mind, the positive things. Okay, so understood. So how we can mathematically represent the first law, dq will be equal to du plus dw. Okay, if we are considering t as constant, T is constant, what will be delta U? Delta U is equal to 0, or du will be equal to 0. Okay, then what will be dq? dq will be equal to dw. Okay, dq is equal to dw. dw in another way we can write down. See, work done, we know force into displacement. Force equals pressure into area, area into displacement. Okay, so what will be area into displacement? Into V. P into V. In that way also we can represent. Okay, that one we will study in the next class. Now this one, till here you understood what is Zeroth law, internal energy, work done, and equilibrium, thermodynamic equilibrium. What is meant by thermodynamic equilibrium? Thermodynamic state or system, all those things you understood, right? So first law of thermodynamics also. Okay, in the next class we will be continuing the rest of the portions. Okay, I hope all of you understood all those things, and if you like the channel, please don't forget to subscribe. Thank you for watching. Bye.